Hello guys, in this video I will explain about Spark standalone architecture. In previous video I already told about, I explained Spark architecture with Yarn. So what is the standalone, what is the Yarn? I told you those are cluster manager. So this standalone or this Yarn is comes under cluster manager. What is the cluster manager? Meaning of the cluster manager. So meaning of this cluster manager is, let me write these things. Okay, so what is a cluster manager? What is cluster manager? Cluster manager will manage the resources for our cluster. So you have a cluster, we have a one master node, and we have a four worker node in our system. We configure that this is our cluster, and we will run our Spark inside that cluster. So this cluster manager will what will do? It will try to manage the resources for our application, for our job, for our Spark job. Main job is the managing the resources. So there are different type of we have a many option in this cluster manager. We have a one option is EON. This is the one cluster manager. We have a Mesos. We have K8. I mean Kubernetes, and at last we have standalone. Standalone is comes by default with Spark. Okay, this is the by default. Okay, this is the by default comes with Spark. But in industry mostly we use this EON. Spark with them. This is the industry trend, but Spark come with this standalone cluster manager. Okay. Today I'll discuss about this because interview can ask question from here. Okay. So you should know. So this is our diagram. We have a driver program. We have a in our cluster we have a 3 worker node and we have one master node. Okay. Now when you are and we have this client. Okay. We'll come later in this part. Okay. So we have a standard, we have a master node, we have a 3 worker node. That's it in our cluster. That's it. That's present in my our cluster. So now when we are opening one Spark terminal, or that time one Spark signal will create. Okay. Now when we are now opening Spark console and we are writing, we are submitting our Spark submit command. When you are submitting the command, that time this driver will create. Okay. What the driver will do? Driver is responsible for analyzing the work, what is the job, and dividing that work in many tasks, and distribute the task, and schedule the task and monitor the task. So when client is submitting the job application, it will create one Spark will create a driver for that application for every job. For every job, we have a individual driver. Okay, you should remember. If we are submitting, there is 100 jobs. There will be 100 driver. For every job, Spark will create one unique driver. Okay. When submitting job, Spark will create a driver. Inside driver, you have a Spark context. What is that driver? Driver will do. Driver will try to analyze your job, divide the work in many tasks. What you have to do in that? No, what code you write. According to that, it will try to divide the task and distribute the task and schedule the task and monitor. That's the job of the driver. Then Spark context. What is Spark context? So this is come under this is one JVM process, nothing else. It will try to hold the information about the executors, and it will try to do all other information. Also, it will try to hold the information about the executors. Now, when request come into this Spark context, it will send to standalone cluster manager. Here, what it will do? It will try to understand the job and it will try to request that for this job we need this much of resources. Okay. So for this job, if so standalone will request to the Spark context that for this job I need 3 executor. When standalone is requesting for resources, Spark context will allocate those resources to the standalone manager. Let's say Spark will tell, if you need three executor, I can give you. Let's take this three executor. Now standalone manager will launch the executor in this work node manager. Okay, so standalone is requesting the resources that I need this much of executor, and when those resources are allocated by Spark context or Spark context, that time standalone cluster manager will launch the executor in those worker node. What we have in our cluster? See, worker node 1, worker node 2, worker node 3. Now what will happen? Now our driver program or Spark context or Spark our driver will launch the task inside the executor. So I already told you what is the executor. Executor will take partition as input. Okay. So you can equivalent executor equal to task equal to partition, number of tasks equal to number of partition. Okay. It depends on the partition. Let's think we are writing on code, PySpark code, like we have to find the top value among this data set, and we have one big data set, and we are writing code. We are loading that data set in our PySpark code, and we are trying to find top. Now when we are trying to submit that job, Spark driver will load the data set, and it will try to send the data set in the worker node, in the executor. Okay, it will try to load those data set here in distributed way. Okay, it will try to partition that data, and it will try to load here in this worker node, Now for that, for job one, if you think one scenario for job one, we need only 2 executor, but in our cluster we have 3 executor. So let's think driver will partition that data and load those data in this worker node 1, worker node 2. Then worker node 3 will be empty. Okay, there will be no data. If you think there is no data in worker node, so we have a data here for our job 1, we have a data here in worker node job 1. Now what will happen? When driver launch the task, okay, so standalone is requested for resources, driver is allocated those resources to the standalone will launch those resources, launch the executor in this worker node. Now Spark will launch those tasks, okay, inside those executor where you have a data. It will not launch the tasks here, because we don't have those data for that job, so it will not unnecessarily launch those tasks here. Okay, the tasks will take in partition as input. Okay, it will take partition as input, and we have the other code. It will run those code on the data. On this data, stack will take in partition as a input and run our code on this task. On this task. Let's think we have a 500 MB data, and we have a 2 partition here, one partition here, or partition. Okay. Now we are finding top on this partition, on this partition 1 data, on this partition 1 data, on partition 2 data. So we have a 2 partition of the data. So we are finding top from this partition data. We are finding top from this partition data, but our main aim is to find that top value or first row from whole data. But in this executor we have only some partition data. Okay, let's see, we have only 200 MB data. Here we have 200 MB data. Now how how Spark will group by this thing, because we have to find from whole data set, but we are doing parallel processing, so we distributed the data. Now we are executing, we are launching tasks on those data, on those partitions individually, separately. Now we have to group by. We have to find top from here to here, from this data set to this data set. So how the Spark will store the intermediate output from this from this task and from this task. For that, Spark will store this intermediate result of this task in some persist memory, okay? In some persist memory, persist memory. I'll I'll discuss this thing in detail later video, but we have a three option. We can store in our intermediate data. We will store those intermediate data in persist manner. Persist manner. We have a three option. We have a only memory option. We can store data in our only memory intermediate result. We can store intermediate result from stacks 1 and stacks 2 in only hard disk something and memory and hard disk. So it's depend on your criteria where you want to store. Okay, I will explain this thing later. Now you just understand Spark can store data of this intermediate result of the stacks 1 in some memory. Okay, now so the Spark is storing the stacks 1 result and this stacks 2 result some in intermediate memory, and from there and launching task on, and Spark will again launch the task on top of this data, on top of this intermediate result, because Spark have to find the top from this whole data. Okay, so again Spark will launch one task, maybe here or maybe this worker node, maybe this worker, maybe in this worker node. Otherwise, it will create one executor and it will launch again that task on top of this data set to find that top of whole data set. So that is the scenario. Okay, and worker node, this executor will try to always send a heartbeat node to the driver to to convey that I am alive, I am not down. Okay, so let's think one executor is down. What will happen? Spark context Spark will create another executor to complete the job. So that is not a problem. You can say that if the Spark executor is down, what is about data? Data is also gone, but Spark maintains some replication. Spark have a replication factor, so it will replicate the data in another worker node. And if this is dead, Spark will launch some executor here, similar or another worker node. So we don't have to worry about replication. But if we are using HDFS, then it is by default come with like replication of block, so we don't have to worry of those things. But I don't want to say about HDFS now. Just remember a Spark is a replication factor, so you don't have to worry about data loss here if the worker node is down. Okay. Now what do you want to say? What is the other problem we can face? We can have that this resource manager is down. For this, we have a zookeeper. We can have secondary standalone resource manager. If this is down, the secondary will come into picture and it will be replace this standalone manager. So if one standalone manager is down, so we will configure that we have a three standalone manager. One is active and two is passive. If one is down, this passive resource manager will come into picture. Cluster manager will come into picture. That's how we can maintain this issue. So that is the standalone point of view of the Spark. Okay, and we have a you can go through this standalone architecture in Geek for Geeks or Spark official website. They will explain it very thoroughly. I just give you the I just giving you the overall scenario what is happening inside Spark standalone. Interviewer may can ask the question from here. Okay, so that's it about the standalone. So Spark driver is a main thing. Okay, it will try to analyze the work. It will try to divide the task. It will try to give the resource to the standalone research manager. Research manager will launch those executor in the worker node, and driver will start context will launch the task. Stacks is what? Stacks will take our partitions data as a input, and in top of those partition data to run our code. Okay, that's it. That's the standard architecture. So we have a two mode to run our Spark what I can say, Spark code. Okay, we have a two modes. One is two mode to run our Spark submit command. One is client mode, one is cluster mode. Okay, cluster mode. Okay, so inside in client mode the driver will be in our local machine. It is the client machine. So when we are doing that Spark submit command, okay, when we are adding the Spark code and we are running this, that time we can say this our local setup is like a client mode. Okay, okay, our driver will be our client machine. So client machine, and this is our cluster. Now we have this worker node wn something w2. Okay, so in client mode driver will be in our local machine. So if our driver goes down, this job is dead. Okay, so you are running some job in our local machine. If our local machine goes down, that job will fail. Am I right? So this is the basic concept here. So if our local machine is down, then there will no way to run our job. Okay, so in industry they don't use this. Okay, because if that machine goes down, a client machine, then driver then the job is finished. So they prefer to, this is our client mode. So in client mode our driver will be in our client machine, but in cluster mode, sorry for my handwriting. Okay, I have to modify my handwriting. So in our cluster mode our driver will be in cluster. Okay, this is our client where we are submitting. This is our cluster. So cluster worker node 1 2. So in cluster mode we have driver inside this worker node. We have driver inside the worker node. So by chance if this client is gone, still this job will going on, because driver, the main thing who will monitor, will divide those tasks, will assign those tasks in our cluster. So this job will going on. That is the advantage of cluster mode. And in industry they use this cluster mode. They don't use client mode. So if you compare with Sparkian, there the if it is a cluster mode, if you think about Spark with Ian, just remember this thing. Interview gonna ask Spark with Ian, if it is cluster mode. Interviewer can ask this question. If it is cluster mode, the driver will be in application master, AM master. In worker node This is in no the driver will be application master. Master will be inside the cluster. Okay, you should remember. So application master will be inside the cluster in Spark VDN, and the driver will be in application master. This is the one interview question. They can ask when we are in cluster mode, which is Spark VDN architecture. Driver will be present in which node or which message something. So you have to say driver will be in application master. Okay, interview can ask this question. Okay, that's it. That's it in this video. I hope you able to understand the Spark standalone architecture, also Spark EN architecture. Spark EN architecture I already explained in previous video. So that's it in this video. So in next video I will do coding because I already covered a lot of theory. It's time to start our coding. We'll solve many questions with PySpark. That's it in this video. Bye. See you in the next video. If you like this video, subscribe, share with your friends, and hit the like button. That's it in this video.